Normally open contacts represent any input such as a switch or sensor, a contact from an output, or an internal output. If the logic is true, the contact closes, and allows the power to flow from left to right. If the logic is false, the contact remains open, and power does not flow from left to right. Normally closed contact, as the name implies, is a contact that is normally closed. If the logic is true, the contact opens and prevents power flow. If the logic is false or zero, the contact allows the power to flow. Normally open coil is used for an output instruction. It is used to represent an external digital output or an internal relay. Normally de-energized coil is used to represent an output signal that is normally off or de-energized and will become on or energized when all the inputs on a rung preceding this coil are true. Normally closed coil is used to represent an output signal that is normally on or energized and will become off or de-energized when all inputs on a rung preceding this coil are true. Consider a simple motor starting circuit. Assume that A is the start button, B is the stop button and C is the output that tells the motor to run. Imagine power flowing through the ladder logic example. When the operator presses the start button, power flows through the contact labeled A. The slash contact means not on or off. So assume that when the stop button labeled as B above is not pressed, power flows through the B contact and powers the output labeled as C and turns on the motor. Note that you have another contact labeled C below the contact labeled A. This is called a sealed circuit, since contact C seals in contact A. If it was only the top rows A, B, and C, then every time the operator took their fingers off the start button contact A, the motor would stop. But contact C is placed in parallel with contact A, so that once the output C turns on, it remains on. The only way to stop the motor is to press the stop button contact B.